Welcome to the weekly challenge videos. If you like this kind of content, please like or subscribe. And if you'd like to see even more of these challenge questions, I have a lot more on my courses website, link in the description below. A student is throwing a ball at an angle theta to hit the top of a fence located at distance d with a height h. Derive an expression for the initial speed v0 in terms of theta, dh, and fundamental constants. Okay, so let's look at our horizontal and vertical variables. The displacement in the horizontal direction is d. The initial velocity in the horizontal direction, well, because I have v0, or I'm trying to figure out v0, but in terms of v0, the horizontal speed is v0 cosine theta. Okay. Final velocity is also v0 cosine theta, although not that important. The acceleration is 0, and the time is unknown. Vertical. Well, let's say up is the positive direction in this case. Previous problem I said down was positive, but usually if it's not falling from where it starts, I make up positive. So the displacement is from here to here, from this point to this point. I would like it to rise a distance h. And the initial velocity is upward component v0 sine theta. Because remember, we look at this triangle. This is v0. This is the horizontal component, v0 cosine theta, and the vertical component is v0 sine theta. It's upward, so it's positive. Final velocity unknown. Acceleration is downward, so I'm going to make that negative g, because it's downward. Downward's the negative direction, because acceleration, when you're doing projectile motion near the surface of the Earth, acceleration is always down, and the time is unknown. Okay. So let's set up some equations here. So I know three variables, and usually with projectile motion, you want to connect them with time, right? So that's the key part here, is the time. So this equation, delta x equals v0t plus 1/2 at squared. On the projectile motion side, it's going to be d is v0 cosine theta times t. And on this side, it's going to be h is v0 sine theta t minus 1/2 gt squared. Now I would like to connect the two variables in some way, and maybe I would. This one is pretty easy. T is equal to d divided by v0 cosine theta, and then plug that in for t. Now this makes it kind of messy, but yeah, I think that's what we're gonna do. We're gonna do h v0 sine theta times d over v0 cosine theta minus 1/2 g times d over v0 cosine theta squared. Now this one is actually not solvable directly for v0. Actually, sorry. We want to solve for v0. Actually, it is solvable. I don't know what I was thinking. I thought we were solving for theta. Theta is not solvable, but we're given a theta. Here you can see the v0s cancel. So this is d sine theta over cosine theta. You could make the sine theta over cosine theta tangent theta if you wanted to. This would be minus 1/2 g d squared over v0 squared cosine squared theta. And now I want to solve for v0. So I'm going to move this to the other side. Or actually, I'm going to move this to the other side and move the h over. So I'm going to have 1/2 g d squared over v0 squared cosine squared theta is equal to, I'm going to make this d sine theta over cosine theta minus h. Okay. And then I'm going to move the v0 squared up and move that stuff down. So I'm going to get 1/2 g d squared divided by cosine squared theta times all of this I'm bringing down, d sine theta over cosine theta minus h is equal to v0 squared. So v0 is the square root of I'm going to bring the 2 down to here, right? So 1/2, you can bring the 2 down. So that's going to be the square root of gd squared over 2 cosine squared theta times d sine theta over cosine theta minus h. Now this is a physics class, not a math class. It's okay to leave it like this. There's a few things you could do to simplify if you wanted to. The d could be brought outside. The cosine squared. The d squared could bring outside with the d. The cosine squared could be brought outside with the cosine theta. Or you could cancel the cosine with one of those down there. So if you wanted to simplify it a little bit more, but it's not a huge deal to leave it like that.